Today's Algebra 2 lesson is from Chapter 10, Lesson 3, Defining and then How to Use Probability. Probability is really just a calculation for the likelihood that an event will occur. You can write it a variety of ways. You could write it as a fraction, as a decimal, or as a percent. When you write it as a decimal or a fraction, it always ends up being a number between 0, meaning it's never going to happen, and 1, meaning it definitely will happen. If it's a percent, it's either 0% or 100%. There are two types of probability. Theoretical probability, and this is what would happen, well, in a perfect world, if everything happened exactly as it should. To make the calculation, you'd say probability of event A occurring would be the number of possible desirable outcomes, meaning whatever it is you're checking to see what you're hoping the outcome will become, divided by the total number of possible outcomes. So here's a theoretical situation for you. If, hypothetically, there were 100 babies born in our town last year, theoretically, you'd say 50 out of the 100 births would be boys, and 50 out of the 100 births would be girls. Theoretically, when a baby is born, it's going to either be a boy or a girl. So theoretically, half of the time babies are born, they should be boys, and half they should be girls. But we know that realistically it really doesn't always happen that way in theory. Think of rolling a dice, a standard 6-sided dice with the numbers 1 through 6. Theoretically, if you rolled that dice 6 times, 1 out of those 6 times, it should roll and give you the number 1. 1 time out of the 6, it should give you the number 2. 1 time out of 6, it should give you the number 3, and so forth. Because on the standard 6-sided die, there's only 1 of each number that would be possible to land out of the 6 total different sides on the dice. So in contrast to theoretical probability, there is also experimental probability. This is when you actually perform an experiment if you're actually looking at real data. This probability would be calculated the number of actual occurrences divided by the number of trials. Or if we look at that hypothetical example, if we were to call our local hospital and were to have found out that there were 100 children born in our town last year, and they told us 52 girls and 48 boys, the experimental probability for having a girl would be 52 out of 100. The experimental probability of having a boy would be 48 out of 100. Based on real data, based on real trials. If we think of the dice example, most likely if you rolled a dice 6 times, most likely each of those 6 rolls would not give you a different number. Possibly you could have roll a 3 2 times, roll a 4 once, roll a 5 2 times, and maybe roll a 6 once out of the 6 rolls. Experimental probability and theoretical probability typically do not yield the same outcome. Let's switch gears. Let's take a look at an actual example in a different kind of a problem. Theoretically, if I have a bag that holds 10 marbles, 2 are blue, 3 are pink, 4 are green, and 1 is orange, what is the theoretical probability I could draw a pink marble? Well, how many pink marbles are in the bag? There's 3. How many total marbles are in the bag? There's 10. So my probability would be 3 out of 10. What is it I wanted? I wanted a pink marble. There were 3 possible ways I could pull out a pink marble. And then there were 10 total marbles in the bag. Probability of drawing an orange. Well, how many orange marbles in the bag? 1 out of the 10 possible. Blue marbles. There's 2 out of 10, but you should still reduce your fraction and write it 1/5. Theoretical probability of drawing a green marble out of the bag. Well, there's 4 out of 10 that are green, so 2/5 would be your probability of drawing a green marble. Let's now look at odds. Odds, like probability, could be written as a fraction, but also you could put a colon in between the two numbers. It differs from probability in that When you calculate odds in favor of an event occurring, you are looking at the number of desirable outcomes, that is what you're hoping, what you're in favor of having happen, divided by the number of ways that are when that desirable outcome does not happen. I tend to think of this one as it's what you want divided by what you don't want. So if I was going to roll a die and I wanted to know what are the odds of rolling a 3, what do I want? I want a 3. How many 3s are on that 6-sided die? Only 1. How many sides of that 6-sided die are not 3s? 5. So my probability for that example would be 1 out of 5. Note that the sum of the numerator and the denominator always sum to the total number of possible outcomes. On that 6-sided die, there are 6 possible total outcomes, and the numbers 1 through 6. My example was odds of rolling a 3. Well, there's 1 3 on the die. There's 5 sides that are not 3s. We also can calculate odds against. That's when you're basically comparing what you don't want, the odds against it happening, to the odds of it actually happening. So I'm kind of flipping it, don't want and want. More technically, we could say it's the number of not desirable outcomes divided by the number of desirable outcomes. What are the odds against rolling a 5 on my 6-sided die? Well, how many sides of my die are not 5s? 1, 2, 3, 4, and 6. It means there are 5 sides on that die that are not 5s. The denominator, how many sides are 5s? Just 1 of them. So my probability there would be 5 over 1. And again, the sum of the numerator and the denominator is the total number of possible outcomes. Odds in favor of drawing a heart. Typically, we think about probability and odds with decks of cards. You're thinking, what are the chances you could get the card that you maybe need to get that royal flush or whatever particular hand you need in whatever game you're playing. So the odds in favor of drawing a heart, you're going to ask yourself, how many cards in the deck are hearts? Well, there's 13 hearts. Then, how many cards in the deck are not hearts? That'd be 39, because 39 and 13 give you 52, and that's the total number of cards in a standard deck. Odds in favor of drawing a heart, 13 to 39. Odds against drawing a jack, you're going to ask yourself, how many cards are not jacks? Well, 48 cards are not jacks, so your numerator is going to be 48. The denominator is how many cards are jacks, and that would be the number 4. Again, 48 and 4, that sums to 52, the total number of cards in the deck.